So the question becomes, what do we do? How do we compute to figure out that a pixel in an image, the pixel at some location xy, is actually an edge pixel? That is, that it lands on an edge or is part of an edge somehow. To think about this, we have to return to our idea of an image's function. So you remember, here's our comedian, and this was two different representations of the same function. One just happens to be shown to you as a picture, so you're used to seeing that, although it's pretty scary. And the other is shown as this height map, where the height was proportional to the intensity. And the thing that's clear is that these edges, right, so this edge by the side of her face there, is really a steep cliff by the side in that function, okay? And what we're going to look for fundamentally for edges are going to be these steep changes somewhere in that image function. So it sounds pretty simple, okay? In some little local neighborhood, can I determine that I'm at a location where there's going to be a very strong change? Doesn't seem so hard. Well, there are two things that we have to sort of answer in order to be able to do this. If we're trying to look at a neighborhood with strong signs of change, we have this question of, well, how big is a neighborhood? And then, what do you mean detecting change? How much of change is change? And how are we going to determine exactly where that change is? So here's an example of a function, and the idea is that, probably the edge might be thought of as like that. Our first problem, of course, is we don't get to do that. We have to pick the pixels that we say are the edge, right? We don't get to say it's between. Well, we could say it's between pixels, but we tend not to do that, right? So the idea here is that the 80s are on one side and these 20s and 30s are on another side. So we have to try to go about finding those.